Key to integer float division is to treat the data type separately from the math, in this case, division. For example, a variable a has been declared an integer, so the computer is expecting a number without a decimal point, whereas the variable b has been declared a float value, so the computer is expecting a number that includes both a decimal point and decimal place or places. Once the division has occurred, the computer will be storing the answer as an integer, regardless of what the mathematical answer is. When dividing, if there is a float value in the numerator or denominator, the answer will always be a float value. The only time your answer is an integer is when the top and bottom numbers are both integers. Okay. In this case, when dividing an integer by a float value, the answer will be a float value. Okay, so 5 divided by 2.0 is going to give you a 2.5, but the computer is only able to store an integer. So only the 2 is stored. The 0.5 is truncated or cut off. If x was assigned as a float data type or float value, the entire answer 2.5 would be able to be stored. Pause the video and try this example. Both variables have been declared as integers. So the math gives us 2.5 as an answer for 5 divided by 2. But this is integer divided by integer, so our answer can only be an integer. So we are going to truncate off the 0.5, so our actual mathematical answer is going to be 2. When we go back to our code, x is declared as a float value. We don't get the 0.5 back. Instead, the computer converts the integer of 2 into a float value by adding a 0.0, resulting in 2.0. The same patterns apply for double data types as well as float.